Page 2. Alright, we're still doing simplifying problems. Here again we want to get rid of the parentheses first, so I can just rewrite the first trinomial without the parentheses. I don't have to do any modifying. But after I write this out, I have to distribute the minus sign through this second trinomial, right? So this is going to become minus 2ab squared minus a squared b squared minus 5a squared b squared. Alright, so now we're ready to start looking for the like terms. So let's start with this guy right here. Let's just start with the one out in front. 3a squared b. Okay, do I have another term where I have an a squared that's paired with just a b by itself? I'm looking, and I don't see one right away. Ooh, you know what? I just realized something. I wrote this down wrong. This would be a squared, not a squared b squared. It's just a squared b. So there is a like term right there. So what's 3a squared b minus 5a squared b? Well, 3 minus 5 is a minus 2, so this would just be minus 2a squared b. Okay, so these guys are done. Now let's take a look at this. I've got a minus 4ab squared. Okay, so let's take a look. Is there any other place where I have just an a, but it's paired with a b squared? Not there, but right here. Right there. Minus 4ab squared minus 2ab squared. They're like terms. So what's minus 4ab minus 4ab squared minus a 2ab squared? Well, a negative 4 minus 2 is going to give you a negative 6. So it's negative 6ab squared. Alright, so we're done with those. And now we just have a positive a squared b squared and a negative a squared b squared. They're going to cancel each other out. And so we're done. In other words, when I take that and I subtract, it's like 1 minus 1 equals 0. So we don't have to worry about the a squared b squares. They undo each other. And that is the answer for number 8. Okay, now we're on to multiplying, which I like better. So we got two monomials here that we're going to multiply together. Let's just start with the numbers. What's 13 times 5? And the answer is 65. Okay. So next, let's look at the m's. What's m to the third times m to the second? That's going to be m to the fifth. And then finally, I have n times n squared. That's going to be n to the third. And we're good for that one. That is the answer to that one. Moving on to the next problem. Now all we really have to do is distribute a minus 3x into this trinomial here. So what's minus 3x times 2x squared? That's going to be minus 6x cubed. Okay. What's minus 3x times minus xy? Well, that's going to be a positive, right? Because if you have a minus times a minus or a negative times a negative, that's going to be a positive. So it'll be positive 3x squared y, right? Because an x times an x will give you an x squared. So that would be positive 3x squared y. Now, we do minus 3x times 4y squared, so that's going to give us a minus 12, right? Minus 3 times 4 is a minus 12. And then xy squared. And we're done with number 10. Number 11 is going to be a little bit more complicated because we have to break this up first. We're going to say that this is like x times this whole thing, 2x squared plus 7x minus 3, and then minus 5 times the entire thing again, 2x squared plus 7x minus 3. Okay, so what are we going to get? X times 2x squared, that's going to give me a 2x cubed. X times 7x is going to give me 7x squared. And then x times minus 3 is going to give me minus 3x. Then I have minus 5 times 2x squared, that's going to give me minus 10x squared. Minus 5 times 7x is going to give me minus 35x. And then finally, minus 5 times a minus 3 is going to give me a positive 15. And now at this point, we're doing with this problem what we were doing up here. We're looking for like terms. Okay, so I've got 2x cubed. Are there any other x cubes anywhere in this? No. So I need that one. I'm going to keep that one. 2x cubed. Okay. What about x squareds? I've got one there. I've got one there. So what is 7 minus 10? Well, that's a minus 3x squared. So I'm done with them. Next, I got the x's. I got a minus 3 minus 35. That's going to give me a minus 38x. And then the only thing I have left is the positive 15. And we are done with number 11. Okay, number 12. Now we get to use my favorite method of multiplying polynomials, and this is a special product. So you can see that it's z and z, and then plus 12 and minus 12. So that means there's not going to be any middle term. All I have to do is do z times z, and that'll give me z squared. Positive 12 times negative 12 is negative 144. Now you could FOIL it out the long way, and I'll go ahead and do that. I mean, you'd get z squared plus 12z minus 12z minus 144. That's what you would get if you actually FOIL the whole thing, and then you can see that these terms just undo each other. They cancel each other out. But I would try to recognize that special product right there, so you can just eliminate that step and just say, okay, z times z is z squared. 12 times minus 12 is minus 144. You're done. Okay. Next one's 13. This one we'll actually have to do a little more work. We're going to FOIL, do the front terms. 2 times 4 is 8. X times x is 8 squared, so 2x times 4x is 8x squared. Then we'll do the outer here. 2x times minus 5y is going to give me a minus 10xy. And then the inner here, 3y times 4x is going to give me a positive 12. And then I'm going to write it as xy. I'm just going to put the variables in alphabetical order so I can see the like terms more easily. And then last we got 3y times minus 5y, so that's going to give us a minus 15y squared. And like I said, we can see that these are like terms here, so we can combine them. What's negative 10 plus 12? Well, it's 2. So what I'll get is 8x squared plus 2xy minus 15y squared. And we're done with problem 13. Okay. Problem 14 is the square of a binomial, and that means that this is just the same thing as 3x plus 4 times 3x plus 4. So we can FOIL this one. 3x times 3x is going to be 9x squared. Then I'll have a 12x plus another 12x, so that's 24x. I'm going to move a little bit faster on this one because I hope you guys got the gist of these by now. And then 4 times 4 is 16. So there we go. 9x squared, 24x plus 16. There's our answer. Okay, last but not least, we've got a division problem. And I think the best way to do these is to break it up into two separate terms here. So we're going to have 4r5 s squared divided by 2r squared s squared minus 6r squared s cubed divided by 2r squared s squared. Right? This up here is actually this expression simplified because it's a common denominator, but you can also split it back up. And that, I think, is the best approach for a problem like this, because then we can just do each of these individually, and I think it's going to be a little bit easier. Let's see what happens, though. So 4 divided by 2, we'll do the easy part. That's just 2. R5 divided by R2 is going to be R3, right? You subtract the exponents. Well, look at what happens here. What's s squared divided by s squared? Well, that's just, they undo each other. That's like 1. So they're out of the equation, so to speak. So all we're left with is 2r cubed. Okay, let's do this one over here. So I'll transfer the minus sign down there. 6 divided by 2 is 3. Well, look here. What's r squared divided by r squared? Again, they undo each other. And so we just have s to the 3 divided by s squared, so that's going to be s to the 1, right? Or just s. So there is the answer. It's going to be 2r cubed minus 3s, and there is page 2 of the practice test.